Zipline, the real reason we visited Rwanda, is working to solve this with their fleet of autonomous drones, each capable of carrying 1.6 kilograms of medical supplies, about the weight of 3 500 milliliter blood bags. These amazing little drones have a ton of geeky engineering design that was influenced by Zipline's design philosophies. Several unique factors influenced their designs. The first is the speed the plane needs to get into the air. The moment an order comes in, the clock has started, and Zipline aims to have their drone in the air in as short a time as possible. This is, after all, an emergency, and seconds count. Currently, they are averaging just 5 minutes from order to launch. That's the time it takes for an order to arrive in their on-site pharmacy to launch. But for now, let's focus on some of the engineering challenges. Getting a plane into the air that quickly is pretty astounding. Some would struggle just to get a drone out of its case and flying in that time, and Zipline have come up with some amazing solutions to reduce those seconds. Just like a DJI drone, Zipline's plane needs a GPS connection in order to fly, as they are not piloted, they're autonomous. If you have ever flown a drone, you know it can sometimes take a little while for the drone to boot up and make a connection with the GPS satellite. So, to remove that delay, Zipline moved the GPS circuitry from the plane to the battery. This means it's always on and always connected. This innovation alone removed an average of 10 to 15 minutes off the launch time. The battery is one of 4 pieces of the plane that need to be assembled prior to flight. First, the order is placed inside the drop hatch of the fuselage, which is then placed on the launcher. The wings are then attached, followed by the battery. This modular design makes the plane much easier to handle, allowing staff to easily lift it into place. More importantly, it separates components, so if there is a problem found with the wings during the pre-flight check, they are simply swapped out without having to start the entire assembly process over again. Pre-flight checks are often a lengthy process, and Zipline have come up with some cool solutions to hasten this step too. Checking the flight surfaces is done with a mobile app that connects to the launcher system. The launch technicians simply point the phone's camera at QR codes on each control surface, sending a message to the plane to actuate the control surface. The phone then utilizes a computer vision algorithm to make a pass or fail judgment for each control surface. Once the plane is ready and assembled on the launcher, the next time-saving measure kicks into gear. Rather than telling you how this works, I'm going to show you. We spent 2 days at Zipline, and this never got old. The rail uses a pulley and an electric motor to quickly and safely get the drone up to speed, accelerating the plane to its 100 km/h cruising speed in just 0.3 seconds. It launches the same way every time and reliably clears the obstacles in front of it. Takeoff and landing are the most difficult stages of a flight. To avoid having to land at the destination, the plane simply drops the supplies in an insulated cardboard box with a simple parachute, which can then be thrown away, meaning the clinics need no infrastructure to sign up as a client of the distribution center. When the plane does eventually need to land, the procedure to allow it to land with no pilot is even more incredible. Once again, I think it's easier to just show you how it works. It may be difficult to keep track of everything that happened there, so here it is again in slow motion. There is a small hook at the end of the tail boom, which will grab the wire strung between the 2 actuated arms on either side of the capture system. It's hard to see in real time, but in slow motion, you can clearly see that the arms actually raise up at the last moment to catch the hook. The plane is communicating its location in 3D space with the radio receivers next to the platform, allowing the wire to stay out of the way until the last moment, minimizing any risk of collision with the wire. The capture system misses about 10% of the time, but the plane is programmed to immediately detect a miss and throttle up its engines to gain altitude and make another pass.